How are you everybody? How are you today? This is the 9th lecture before the last lecture in our course Advanced Mathematics for the 4th year Statistics English section in Benha University 2020. This lecture is very important and I want from every student to study this lecture very closely because this related to application, direct application for the course of integration application. This is lecture related to integration application or application in integration, so that I want to study this lecture very closely to understand the application related to integration part in our course Advanced Mathematics. Applications of anti-differentiation arise in problems in which we know the rate of change of a function and want to find the function itself. Problems about motion provide many examples, such as those in which the velocity of a moving object is given and we wanted to find its position at any time, since velocity is rate of change of displacement. We must anti-differentiate to find the displacement. Examples: a stone is thrown upwards from the top of a tower 50 meters high. Its velocity in an upwards direction t seconds later in 20 minus 5 t meters per second. Find the height of the stone above the ground 3 seconds later. This is a written and the speaking example, not a direct application, but a speaking example. Solution: let the height of the stone above ground level at time t be h meters. We are given two pieces of information in this problem. Number one, the fact that the tower is 50 meters high tells us that when t equals 0, that is at the moment the stone left the tower's hem, h equals 50. Number two, the fact that the velocity at time t is 20 minus 5t tells us that dh related to height, so that dh related to dt equal 20 minus 5t. We began with the second statement, which tells us about rate of change of a function. By anti-differentiating, we obtain h equal integral sign 20 minus 5t dt equal 20t minus 5 over 2t square plus c. Note, it is virtually important not to forget the c. The constant is integration in problem like this. This is an important example. I want for every student to study very closely and know. Now we can make use of the first statement, which is called an initial condition. It tells us what things were like at the start. To find the value for the constant c by substituting h equal 50 and t equals 0 into the equation 1, we obtain 50 equals c, so h equal 20t minus 5 over 2t square plus 50. Finally, let us go back to the problem and read it again to check exactly what we are asked to find. Find the height of the stone above the ground 3 seconds later. To find this, all we have to do is substitute t equal 3 in the expression we have just derived. When t equal 3, h equal 60 minus 5 over t multiple 9 plus 50 equal 87 plus 87.5. So the height of the stone 3 seconds later is 87.5 meters. Now, this is the last slide in our lecture, and the last speaking in this lecture number 9, solution to exercises. You can find the solution of this exercise number 1, 2, 3, and number 4, but you solve in first and check your answer by this solution. This is a direct application and a direct practice about the application of integration and antiderivative of differentiation. Thank you for everybody, and see you in the next lecture in online course, lecture number 10. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.